Okay, so in this part of our discussion, we will try to use this standard and give some of the samples. So chapter A, general provision. So this is the other code, AISC. This is AISC 360. So general provision. Yan, AISC 360. Okay. So reference codes in standards. AISC, material. Okay, so merong mga ano. So there are a lot of references about codes, standards, specifications, materials, structural design drawings, and specification. So when we say design, it composed of design drawing, plans, specification, and the computation, including the computation. Okay, so let us proceed to the next. So chapter 2, design requirements. So, specification shall be consistent with intended behavior of the framing system. Because we are talking about steel design, naturally we will start with frames, okay? Building frames, loads and load combination. We already talked about initial discussion about this. Loads. What are the symbol for different types of loads? Live loads, dead load, rain loads. Okay. What are the symbols? And what are the 7 formula for strength design and 8 formulas for stress design? So there are all in all 15. Okay. So when we are talking of strength design, we have 7 formula for load combinations. Okay. Oh, this is the what? This is the reference again. No? So we already discussed these things on that part. Okay. On that part wherein we are given the different formulas. Okay. The design basis. So now let us talk about the different design basis. So number 1, load resistance factor design, and number 2, allowable stress design. Okay, so there are 2 types of design methods. Okay, both we will take note of and we will give examples of. Okay, I think it is much better for us to give an example and solve the same example using both methods. Okay, so let us do that. So member properties. So member properties are usually tabulated. So like this one, table B4.1A, B4.1B. Okay, so those are very important. Table of ratios limiting width to thickness. Okay, width to thickness of the element. Okay, width to thickness. Okay, so we need that ratio, meaning you have to measure the width, you have to measure the thickness, then divide. Okay, so divide the width by the thickness. So take note, we are now very familiar with this value. This is what we call yield point, 50 kilopounds per square inch. Okay, so this is now the standard, the current standard. Previously, that is 36 kilopound per square inch. Okay. Pounds per square inch, that is PSI. Kilopounds per square inch, that is KSI. Okay. Another design perspective, design for stability. We are also using that, and we will use what? This one and this one. So P delta and another P small delta. So small letter delta. This is the small letter delta. This is the capital letter delta. Okay, P delta small, no? P delta capital, P delta small. Okay. We'll solve that. There is a problem solving for that. Okay. So calculation of required strength, calculation of available strength. Okay. Required because we are what? When we are doing this, this is what we call so we will use an example of 4-story building example. So I have that document. So take note, another item, calculation of available strength. So what is the required strength? So meaning we are given the the load. We are given the loading, then we are going to solve the required strength for our materials. Okay. So when we are given the materials, we can find out the capacity of this material, how strong it is. So that is the same computation formula, but this will solve the capacity of the material, and this will solve the dimension of the material. Okay, so because the given is the load. Okay. So okay, so let's move on. I will set up. So meron pa tayong ano. Okay, we still have what? About 30